All right, this is problem 20, very similar to the previous problem. The only difference is we're going to be looking at complements of the given probabilities. So we're told that 10% of our patients show up to the emergency room in critical condition and 40% of those die. 3% show up in serious, 30% show up in serious condition and 10% of those die. And then 60% or the rest that show up, so we infer the 60% are the remaining, that they show up stable, and of those stable patients, only 1% of those die. So let's mark out our sample space and break it down by populations. We had 10% showed up in critical condition, and then 30% showed up in serious condition, and the remaining 60% were stable. Of those in critical condition, 40% died. Of those that were in serious condition, only 10% died. And then of the stable, only 1% died. So narrow little slice up here. All right. Now, what makes this problem a little bit different from the previous one is the question that we're asked. Given that the patient survived, so we're not in these tiny areas up here. Our conditional area, the limited sample space, is down here in the survival area. So given that the patient survived, calculate that the probability that the patient was categorized as serious upon arrival. So this is the portion of serious patients that survived. So we're going to do 0.3 times the 10%, not the 10%. If there was a 10% chance they died, there was a 90% chance that they survived. So we're going to use the complement, 1 minus 0.1 for 0.9. And then all the possible ways that a patient who showed up in the emergency room could have survived. So there is serious. Let's do showed up in critical condition next. If 40% died, then of those 10%, 60% survived. And then in stable condition, if only 1% died, then of the 60% that were in stable condition, 99% survived. And then we run that through the calculator, and you'll get 0.2922. And given your answer choices, we could just round that to 0.29. The correct answer here is B.